it follows that var of big Y equals 0.64 var open big X close. So taking the square root of the variance, the standard deviation of big Y is sigma sub big Y equals 0.8 sigma sub big X, equation 2.10. That is the standard deviation of the distribution of her after-tax earnings is 80% of the standard deviation of the distribution of her pre-tax earnings. This analysis can be generalized so that big Y depends on big X with an intercept A instead of 2000 and a slope B instead of 0.8, so that big Y equals A plus B big X, equation 2.11. Then the mean and variance of big Y are mu sub big Y equals A plus B mu sub big X, which is equation 2.12, and sigma sub big Y squared equals B squared sigma sub big X squared, equation 2.13. And the standard deviation of big Y is sigma sub big Y equals B sigma sub big X. The expressions in equations 2.9 and 2.10 are applications of the more general formulas in equations 2.12 and 2.13, with A equals 2000 and B equals 0.8. Other measures of the shape of a distribution. The mean and standard deviation measure two important features of a distribution: its center, the mean, and its spread, the standard deviation. This section discusses measures of two other features of a distribution: the skewness, which measures the lack of symmetry of a distribution, and the kurtosis, which measures how thick or heavy are its tails. The mean, variance, skewness, and kurtosis are all based on what are called the moments of distribution. Moment of a distribution. Skewness. Figure 2.3 plots four distributions, two that are symmetric, figures 2.3a and 2.3b, and two that are not, figures 2.3c and 2.3d. Visually, the distribution in figure 2.3d appears to deviate more from symmetry than does the distribution in figure 2.3c. The skewness of a distribution provides a mathematical way to describe how much a distribution deviates from symmetry. Figure 2.3. For distributions with a different skewness and kurtosis. A, skewness equals 0, kurtosis equals 3. B, skewness equals 0 and kurtosis equals 20. C, skewness equals negative 0.1 and kurtosis equals 5. D, skewness equals 0.6, kurtosis equals 5. All of these distributions have a mean of 0 and a variance of 1. The distributions with skewness of 0, open A and B, close, are symmetric. The distributions with non-zero skewness, C and D, are not symmetric. The distributions with kurtosis exceeding 3 have heavy tails.